My name is Alicia Jones. I'm in your first block, and today I'm going over the Topic 1 Performance Assessment.
Okay, for part A, what we're doing is we're dividing the distance by the time. And for the first stage, the distance is 30. So you do 30 divided by the time, which is 2 seconds, which equals 15 for the first one. So the average rate of change for the first one was 15. And for the second stage, we're finding the average rate of change from this point to this one. And so the distance, the time was 1 second. So you go 1 over, and then it goes from 30 to 90. So then 90 minus 30, which equals 60 over 1, which just equals 60 as the average rate of change. And for the third stage, we're finding the average rate of change from this point to this point, which the time is 1 second, so it's under 1, and then it goes from 90 to 300, which is 300 minus 90, which equals 210 over 1, which then just equals 210 for the average rate of change.
This question says, how would you interpret the rate of change in the context of the trip? The rate of change increases over time, so the rocket is getting further from the ground at a faster speed as time continues. And then it says, what is the function that represents the distance f at time x for the first interval of the trip? And so then you just write that into a formula, and then you do fx equals 15x, because for the first stage, the rate of change was 15.
Okay, to solve this problem for part A, we basically had to find the missing places on the graph. So all you do is write this formula. I'm gonna write it down here. Y equals 1,200 minus 30 times the x is gonna be in there. And then all you do is fill in the time. So for the first time, you're gonna fill in the 10. And so 30 times 10 is 300. And so then when you minus 300 from the 1,200, you get 900, which y equals 900, which then at the 10, you go up to the 900, and that's the next position on the graph. And then you continue to find the different time variables, cross that out, and for the next problem, you'd put in the 20. And so then when you solve it, you'd see where the 20 would go. And to really explain the x and the y-intercept, the x is the time, and the y is how many bottles. So to see at 0, they're producing 1,200 bottles, and then when you get to 20 minutes in, they're only producing 600 bottles. Okay, and to find the y-intercept, we want to look up here. That is 9,000, and then the seconds is at 0. So we're going to do 0 seconds, and then 9,000. Is that meters, units? I'm just gonna write units. Oh wait, meters, okay. And then for the x, it's 50 seconds and 0 meters. So 50 seconds, 0 meters. Okay, and for the domain, it would be the x is more than, or it could be equal to 0 seconds. Or if you want us to write it like this, it's going to be a boxed in 0 because it can't be negative. It can be anything further in the positives. And then for the range, the y is less than or equal to 9,500. Those are the meters. Or if you want to write it like this, it's going to be the boxed in 0 up to 9,500, and then it's going to be another one of the box because it cannot be higher. For part B, it says, for what interval does the altitude appear to be increasing and decreasing? Well, right here in the very beginning, up to 10 seconds, it looks like it's a slight increase. So I'd say from 0 to 10 seconds, it is increasing. And then from 10 seconds all the way down to 50, it is decreasing. So from 10 to 50 seconds is decreasing. Okay, so for number 4, it says find the common difference of the sequence, then write a recursive definition of the sequence. For the common difference, obviously from 10 to 14 is 4, from 14 to 18 is 4, and so the difference, D equals 4. And then for the recursive definition, you would do the AN equals AN minus 1 plus 4. Okay, and so what I did to find the recursive definition was I just filled in the formula, and then I filled in the 10 from there, and then the difference, which is 4, we filled in right there, and then we wrote it out. And then to solve it, we did 10 minus 4, which is plus 6, left the 4 in there, and just filled it in. But in the question, it wanted us to find what is the value of the 12th term. So to do that, I'm just going to write it up here. So then you would rewrite that formula, but then for the n, you'd fill in the 12 equals 4, and fill in the 12 again, plus 6. And 4 times 12 is 48, plus 6 equals a 12. And then 48 plus 6 is 54. So therefore, the 12 equals 54. Number 5 says during an 8-hour day, the cell phone assembly at an adjacent facility is split into 2 phases. The graph shows the cell phone assembly rates for each phase. Write an absolute value function f to model the cell phone production throughout the day. So the absolute value, we're going to put the little x. We don't know what the absolute value is, but then we're going to add the 2,000 and minus the 500. That's what the y is going to equal. Okay, number 6 says when a rocket approaches the moon, engineers need to plan how the lunar modules would land on the moon. They developed 2 plans. Plan 1, at 100,000 feet, the module drops at a steady rate of about 0.5 thousand feet per minute. Okay, so then it would be 100, well, we'll do y equals the 100 minus 0.5 per 1,000 feet, so it'd be x is how many feet. And then for number 2, it says at 150,000 feet, so we're going to do 150,000. Oh, wait a second. Okay, so it's 150,000, which this one was just more simplified, which is why I was confused for a second, minus, we're going to do 1,000 per x, which is how many seconds, but that can be simplified by 1, and then that would be 1x minus 150,000 seconds. Okay, so for part B, it says when would both plans show the module at the same height and at the same time? Verify your answer graphically. So to find out the numbers on the graph, all you have to do is write the formula, which is, we already have the formula, so all we have to do is fill it in, and we know the time is the x, and so and then we can solve it, which would make us come up with these. And then once we get our numbers, we can plot on the graph. We can graph it out on here, or we can go to Desmos, which is what I'm going to do.
Okay, so now I type the formulas into Desmos, and I realized that before when I had that written, that was not correct because a line didn't come up. So it's really y equals 150 minus 1x for that one, and then where they meet with the same time and distance is right here on 150. So it would be 100 minutes, and then the height is 50, so then that is the feet, period.